Hello guys. Welcome to our introduction to programming event. Here's the agenda. First, we have Esmeralda. She has a coding video for everybody to watch. Second, we have Jon Genda. He's gonna present what coding is about, and he also has a special person who's going to also present here too. We also have Lorpu, who is going to do a different coding languages presentation. And then me and Bryan are going to analyze a wolf random name generator, which we created on Visual Studio 2019. And then Victor is going to present on EsRally. And then last but not least, we have Raymond with the math problem solver coding. So let's start off with Esmeralda.
Thank you, Lani.
Yep.
Hi, everyone. Thanks for taking your time to spend with us. I have a video that I'm going to share about introduction. Why am I getting a feedback? Sorry. Okay, so I'm going to share a video about coding the different kinds of languages and other resources you can use to learn how to code. So I'll share my screen right now. Can you just give me a thumbs up if you can see my screen?
Not yet. There you go.
Oh, okay.
We got it.
Thanks. Right. I'll just. Can you hear the audio?
No.
Okay, let me stop sharing. Okay, it should work this time.
Devices connected to the internet. By the year 2020, there will be 50 billion devices connected to the internet. That's a whopping 50 billion. This will undoubtedly create millions of new jobs and require a whole new way of thinking. So how do we help our children learn the skills that they need for this new world? A question that is often asked is, what computer language should I learn? But the truth is, it doesn't matter. Because you don't need any of these to learn how to program. In fact, you don't even need a computer. That is because it's logic and thinking that are most important. When it comes to programming, the algorithm is king. Let's look at a simple algorithm. The local animal shelter delivered bags of doggy treats to a school for the grade 6 students to deliver to those students in grades prep to 3 who own a dog to encourage good pet ownership. So if we ask the grade 6 students to create an algorithm for this, it might look something like this. 4 year levels prep to 3 for each class, for each student in the class. If the student owns a dog, give them a bag of doggy treats. Else, say, sorry. Aww. This example is a simple algorithm. However, if you can understand this, then you are only a short way from this. An algorithm which accesses and manipulates data in the form of a 3D matrix from an image file in order to change specific colors. Algorithms can be practiced without a computer by using everyday events. Making a cake, giving directions, or building something. Things that can also be practiced with algorithms are problem solving, logic, reasoning, and learning about how computers treat information. There are many resources on the internet that can help. There are several drag and drop programs which can help with understanding algorithms and programming syntax and semantics. Scratch by MIT, Hopscotch, Pyonkee, Tinker. There are a few common languages which use simple syntax like Python and Ruby. And there are many organisations which have created materials which can help, such as BBC UK, CS Unplugged. There are also many toys available which help students learn code via interaction with the real world, such as Little Bits, Edison Robots, Arduino and Raspberry Pi.
So I'm gonna pause it here. I just want to show you guys I have a Raspberry Pi here in person. We got this from Genesys Works for our coding class just to learn more about what coding is and yeah, explore other things. So for those of you guys who have don't, I know most of you guys know what a Raspberry Pi is, but I'm just gonna show you it. We use it a couple of times in our class. Uh, so I really thought it was helpful to just learn other parts of coding. And so for, okay, I'm gonna play the video now.
But the best thing that you as a teacher can do is encourage play and experimentation, support critical thinking, and let them know that mistakes are a very important part of the learning process.
Okay, stop sharing. Well, that's it. Thanks for watching. That was just a video just to show what some resources you can use for coding and what some languages that you can use also. Uh, Next would be I'll pass it over to Jon Genda and his son.
Thank you. Let me know when you can see my presentation. It should be a big swirly thing.
Yep, you can see it.
Okay, everyone could see that. All right, so one of the things that's most interesting about programming is that it's really turning out to be one of the most interesting, compelling, and most highly demanded of all of the jobs. So for instance, Google, Apple, and 13 other enormous companies are no longer even requiring college degrees. All they really want is to know, can you do the job? Can you program? And a lot of you might be wondering to yourself, well, what is this programming thing we keep talking about? Um, and one of the things that I like to cover with everyone, first off, with what is programming, is something that's referred to as imposter syndrome. When you start any new task, at some point between the question, what is programming, and the realization, hey, that's not so hard, you're going to wonder, am I a programmer yet? And there's a funny little cartoon to the right of this, which basically suggests that everyone feels like an imposter at some point. So one of the things that we find ourselves doing when programming is we do a lot of Googling. And I have to say, what an incredible resource that is, because software engineering is all about reuse. Most of the things that you need to do as a programmer, a software engineer, an application developer, a script writer, chances are somebody's already done something either exactly like that or almost like that. So what we do is we stand on the shoulders of giants. There's a whole bunch of just incredible resources out there with little code samples and snippets and complete projects where you can just do a simple Google search like, how would I fill in the blank, whatever it is that you're looking for. And chances are you're going to get thousands of hits back that will help you understand exactly how to do that thing. Now, parsing all that information can be challenging, but that's also another skill that can be learned. So one of the other things that we talk about with software engineering is it doesn't help that everybody talks about it with a bunch of different terms. So sometimes we refer to these people as software engineers or application developers or programmers or systems program or automation engineer or UI developer or a UX developer, which is a special kind of UI developer, a website developer. Anyway, for the purposes of our discussion here, if you're writing code or something that looks like code, let's just call that programming. So we can define programming as the process of writing instructions that get executed by computers. The instructions, also known as code, are written in a programming language which the computer can understand and is used to perform a task or solve a problem. Now that's kind of a wordy definition that gets us to, well, programming is kind of a superpower. In other words, a programmer without a problem to solve is not very useful, but we're surrounded by problems. One of the things that you can start thinking about as someone that wants to get into programming is, what are the things around you that could be solved by a computer? And here's the interesting thing. Almost everything that relies upon data or is accessible electronically could be solved by a computer. Things like automating a repetitive task, gathering information, putting it into a report automatically. Conditional logic. If this condition happens, then execute that response. And then there's a new paradigm that's actually entering into broad use, which is called an API. Now that stands for Application Programming Interface, which now that I've given you the 3 letters, what the 3 letters mean, that still doesn't really help you understand what it is. But it's a very simple way of calling a remote computer program to get information or perform operations. So we use APIs at TCF Bank all the time. For instance, anytime you want to transfer money or change your address, you're calling an API that performs that function. And it's a really easy interface for a user interface designer to use in order to make a backend system do what it wants to do. Okay, and the last thing that I'd like to say about that is the possibilities are limited only by your imagination. Like I said, one of the really interesting points I'd like to highlight here is recognizing a problem that can be solved by a computer is kind of something that you need to start thinking about and get good at. Now, one of the things I'd like to do at this point is I'd like to turn you over to a gentleman named Adam, and I'd like him to walk you through what this process looks like in the day-to-day. So like I said, this is going to start up by recognizing that you have a problem and then moving from that point to understanding that perhaps a computer could solve this problem, and then how does solving that problem start to come together. Okay, Adam, if you're ready, you can go ahead and take control. If you need a hand with that, let me know.
So, okay, I will share my presentation. I don't know if you can see it. Is it working or not yet?
I don't see it yet.
There we go.
There it is. You got it.
Okay, so my name is Jon Genda, and I am a team member at True Value Hardware, which is my local hardware store. And I will be talking about designing programs in the workplace. So you see, at my work, I found a problem. This was our dog food rewards program. It was a box full of pieces of paper. And on those pieces of paper were scribbly, handwritten, illegible names, phone numbers, addresses, the kinds of dog food. It is a mess. So I have come up with a software solution in Visual C#. So I'd like to share that with you, what I have so far. Here we go. So this is what some of the code I am working on. Now I don't have a lot so far, but I have built the database. Will it show up, or will it insist on being in a separate window? Let me get that.
The first law of live demos is that nothing ever goes the way you expect it to.
Of course. And now it's dark, which is lovely. Well, okay. If you could actually see the program running, you would see a lovely database that I have built that has all of the information that I managed to decipher.
If you share your desktop directly instead of an application, share one of the windows on your screen and that'll work better.
Okay.
There you go. We can see the code now.
Much
better. There you go. We can see it.
Great. So as you can see, we have each of these. All this useful information that I'm now sharing to everyone while it's being recorded. So and now there's a lot of buttons here, I know, and they're very fancy. None of them do anything yet, but eventually, when the application is complete, I'll be able to search from pieces of information. I'll be able to add new customers. It'll be easy and intuitive to add the bags of dog food. And I suppose I didn't fully explain. with the loyalty program, after you buy 12 bags of the same kind of dog food, you get the 13th one free. So it's a fairly easy task for a computer to solve. Now, I have a process that I've been using while building this program and while I was imagining it and designing it. And it's in just these 3 simple steps. First step is you need to identify a problem. You need an open mind. It is sometimes, you know, if you're at a workplace, it's like, well, it's always been done that way. But you need to be able to take a step back and look at it. It's just like, is this the most efficient way to do it? The second step is to list the requirements for the minimum viable product. That's MVP. So that this step that defines the scope and the features of the project. And you should always keep this one part in mind. What is my program solving? What problem is it solving? Because if you can't answer that, well, congratulations, you have a whole bunch of code that isn't useful for anyone. Step 3 is you need to design the program. So, and this isn't necessarily even, you haven't even opened the program yet. You haven't created the software. You're just imagining how it will look. You're envisioning it. And I'd like to go in a little more in depth on each of those points. So with this, like, as I said before, you need to notice inefficiencies. And as you saw, as Jon was saying, if anything is done on paper, a program can do it as well. And there's a program I'd like to share. It's called OmniFocus. And this is actually this is where I wrote down the minimum viable product list. So, and then I'll be able to check off each part as I complete it. And then in addition, I was able to like separate from that some more advanced features that I might want. And as with the listing the features. So some of my features include write an easy to use and explain program to keep track of dog food rewards. That's like the summary of the whole program. That's what it's solving. So I need to create a user interface with a list of customers and a search function. I already have the list of customers, so I just need to add the search function and I can check that off. You've got need the ability to add, edit, and remove customers. Now, although the functionality doesn't exist with the buttons, I've already added the features. They're in the program, and I'll show that to you here. We've got them in a class data services. So we've got all sorts of different I surround stuff in try catches to make sure it doesn't just crash, because another part of this program is it needs to be durable. Most of the people I work with, you know, they're okay with computers, but they won't put up necessarily with the program crashes every 5 seconds. So you can probably see all that code here. So after the core requirements are imagined, you need to list the features that can enhance the program while staying within the scope of the project. And there's one more thing I want to show you. It is how I designed. I used Microsoft Whiteboard with an iPad, and then I was able to draw these very nice just user interfaces, just imagining every part of the process. And that's it. Do you guys have any questions?
Okay, fantastic. I don't think anyone's off of mute, so we're just going to keep going. Imagine if you had a question, you could ask it, and then we'll answer it offline. Okay, so back to talking about programming. So that was a really good example of programming in the real world, you know, and like I said, I can't reinforce enough that see a problem, imagine how you could solve the problem, and then actually get started. Now, one of the things that I want to highlight is that once upon a time, and, you know, we're talking, you know, we rode around on dinosaurs, you know, a while back. That's a joke. But let's say 15 or 20 years ago, getting started on any of this stuff was incredibly difficult. It would have cost you thousands of dollars just to get the development environments. It would have cost you perhaps tens of thousands of dollars or millions of dollars, and to have the databases to access and the mainframes to program against and all that kind of stuff. So the cool thing about today is that all of those barriers are gone. Almost everything is free. Every programming environment that we've shown you today is free. You can get it. You can get free versions of Visual Studio. You can get free versions of SQL Server. You can get free versions of operating systems. We already talked about Raspberry Pis. For about, literally, there's a $5 computer, that Raspberry Pi computer we were talking about before. It's literally a $5 computer, and it's a full Linux server that'll do everything any other Linux server will do, just maybe not as fast. But it's enough to get started. It's enough to get you coding. Python is a great language, Java is a great language, C# is a great language. All of these things are really easy to get a hold of and can help you get going right out of the box with a few Google searches. So I just wanted to share a couple of ideas. So a lot of times people are like, yeah, but I still don't get it. What is programming? Well, we just showed you a fun little example where you're in the workplace and you notice an inefficient process and you say to yourself, there's got to be a better way. And then you come up with that better way. Knowing how to program can help you just forge ahead with making that better way a reality. What I'm showing you is a picture of a Raspberry Pi, basically a small little camera, a USB camera, and just a wireless thermometer. And this is sitting in my basement right now, and it has been reliably sending me an email several times a day on what the temperature of my basement is. Sometimes you go on vacation or something like that and you want to know that A, your basement hasn't flooded, and B, maybe your heat is still on. So this is just an interesting idea. So like I said, that's extremely low cost. I think the camera cost $29. The Raspberry Pi was very inexpensive, again, maybe $20 or $30. And this system has been working reliably for 5 years. And that's just an example of the kinds of things that you can put together with programming. Here's another little programming project that's also running on a Raspberry Pi. This is very simple. It's a computer monitor connected to a Raspberry Pi, and it sits next to my back door. And every time you go out, you can just glance at it and see, what time is it? What is the weather? What's the current temperature? What's the traffic to a couple of the places that I normally go? Let's say Elk River or Plymouth or, something like that. So it's glanceable. Now, I know that we have phones that can do these things too, but it's kind of nice to have a dedicated purpose computer that just does what you need it to do, that always has the information displayed right now, not after I click on it, not after I take it out of my pocket, not after I wait for it to find my Wi-Fi network. It's just ready to go. So these are fun little examples that can be used with one of these Raspberry Pis. And again, this is a picture of a Raspberry Pi. This is a $5 computer. And you can see how small it is because I'm holding it in my hand there. So like I said, in closing, I'm going to transfer this to our next person in our presentation, and we're going to talk even more about programming. So thank you all. I'm going to transfer it over. I think it was Lani was going to take over next. If you're talking, you're on mute.
Miss Lani, can you hear us?
You're still on mute.
Yeah, sorry, my Wi-Fi went down.
Oh no. You got it back now?
Yep. All right. Next we have Lorpu.
Hi, thanks, Lani. Okay, let me try to share my screen here real quick. Can you guys see my screen?
Yes.
And can you guys see me too?
Yep, we can.
Okay, thank you. Hi guys. My name is Lorpu and I'm an intern at TCF with I was with IT Dexter Support and I'm with IT End User Computing. So today I'll be giving you a little introduction on coding. So I know you guys hear Jon Genda talk about coding, talk about what you can do with coding, and a lot of people are really not familiar with what all of these different things that we're talking about are. So I'm just gonna give you like a basic knowledge out of basic foundation on what these things are. So let's start with Python. So basically, Python name, does this sound familiar to anybody? Have the name Python like have you heard like somewhere before that is not like coding related? And I'm guessing yes because it's actually it's kind of like familiar with an animal. So what is Python? So Python is basically like an open source, it's an open source network for coding, and Python is readable. So when I say Python is readable, I just don't mean that you can just like see Python and be like, yeah, I'm just gonna like read the whole thing. If you actually like sit down to like try to like pay attention to it, to try to like know what it is, you're able to read it as long as you can read and write. And also Python is an open source. So basically you can like use Python to do like a lot of things. You can use like the API in Python. You can use Python on like whatever technology thing you have to use it on. I'm not sure about smartphones. And also, when we said that Python is easy to learn, it is really not hard to learn. Like all you have to do is just like give it like just like put time and like dedication to it. Even though Python is like one of like the highest level of coding, but you can be able to read it. It is open source and you can be able to learn it if you like put time to it. Okay, so now I have talked about Python and we're like, oh yeah, Python is really cool, but where can I use Python? So there where we come to Python platform. You can use Python when you have a Mac, you can use Python there, you can use Python in Linux, you can use Python in Windows, and etc. And the list goes on. So basically you have like access to like all of these things to use Python because they wanted to make it like easy and accessible for like people to be able to access it and to use it, and it's like almost like all purpose programming language thing because you can like use it to do a lot of stuff as I said before, and it is one of like the easiest platform for coding. So now we're done with Python. What do we have next? Let's come to C sharp. Before we can start with C sharp, I know you just see the name and the little hashtag sign. So basically, on my first day of coding class, Jon Genda, he put it up. It was C, and then the little thing I said, oh yeah, that's the hashtag, and then I really didn't know what it was. But if you see this, it's pronounced as C sharp, even though we don't like spell the whole thing out as sharp. So why is C sharp important? So C sharp is one of the most popular programming language in the world. So you can like hear about C sharp. You can hear about C sharp a lot from people, and people are like more familiar with this. And interesting fact, C sharp is like simple to learn and to use. So you can like learn this like really easily and like learn how to use it. Again, all you have to do is just give it your time and your dedication, and you got this. It is not like a world like a challenge to the end of life. You got this. And so also C Sharp is a Microsoft programming language. So now I said Microsoft programming language. I know people are like, oh, so if I don't have like Microsoft on my thing, how can I use it? What if I have Linux? What if I have this? And that's what I'm gonna take you to another interesting thing. So what is C Sharp platform? So C Sharp is written and is used in the NetFrame network. So basically, the NetFrame network, it's typically you can like find it like on Windows, but then as time go by, you're able to like use C Sharp in Mac and Linux now. So all you have to do is just download the NetFrame on whatever you're using, whether you're using Mac or whether you're using Linux. Just try to download it there, and it should be like really easy and accessible for you to use. And next here, we have Java. So basically Java is like also like it's also like very simple, right? So as you can see the pictures, we have like the little open curly bracket thing, and we also have like the same thing in C sharp. They're all like kind of like similar in a way. They are both like easy to learn. And also it helps you like create like a modular programming and like reusable code. So let's say like you use a code in C sharp, when we say like reusable, you're able to like take that code and like use it over again. So it's not like, oh, you already used this, like you have to like write another code. So that's what make like Java like really interesting. And Java is also an open source, so you can be able to like use it being an open source coding platform. And now let's come to Java platform. Like, where can I run Java? So Java, you can actually run it on Mac. You can run it on Linux. You can run it on Windows. Interesting, you can actually run it on Raspberry Pi too. So basically, John just showed us like a picture of Raspberry Pi. Raspberry Pi is kind of like a computer-ish, but you have to like connect it on something, which give you like a really beautiful display. You're able to do a lot. You're able to do like a lot of cool stuff on it. Like, imagine like having like a smart mirror at your place. Like, you go like, let's say you go brush your teeth in the morning, you have like all this cool stuff on your mirror. You have the time, you have the date, you have the weather, and all this cool stuff. So Java, you can actually like use Java on the Raspberry Pi, which make it like even more cooler. So Java is, yeah, that's it for Java. And also etc. So it's not just these four things. There are other places that you can actually run Java, but we only haven't like talked most about that. I'm just giving you guys like the basic of it. And interesting fact. So remember when I talk about Python, when I asked it, is this familiar? Have you ever heard about it? Because I knew I was coming to my interesting fact. So it's actually on the it's also on the Mount Platform Flying Curious. So basically, this was a movie. It's probably not gonna like be new to this generation. It's not something that we'll actually like want to watch a lot. It's a little bit old, but there where they actually got Python name from. They name it after the snake Python that was actually in that movie, but it's not like on the screen. So yeah. And then also back to Java, more than 3 billion devices run Java. And I thought that was like really cool. Like 3 billion Java. And that was like, it's like so mind blowing to know that how many people actually like use these devices or this platform every day to do their day-to-day work. And this brings me to thank you guys so much for listening to this presentation. I really hope you did learn something from here today, even if you're not like a coder, but you're able to like see these things, places and be able to like, yeah, I recognize that from the presentation that Lorpu gave. And thank you.
All right, thank you so much, Lorpu. Next is me and Bryan, and we're going to be presenting our wolf name generator, which we learned from Jon Genda's class. So let me share my screen here. Let me know when you guys see it.
We can see it.
Yes, we can.
All right, so Bryan, you want to start?
Sure. Give me a second. We're showing off how to edit the UI, correct? Lani?
Yep.
Okay, so I probably want to share my screen instead, so I can show them how to do it. Right?
Yeah, go ahead.
Give me 1 second. Give me one. I think it's this one. Okay, so we have a wolf name generator that our team has been working on or worked on in the past. And the way we modified the UI or the background, the background of the UI, I guess, was through a simple, but I mean, there's multiple ways to do it. Of course, Jon Genda could probably point out multiple ways to do it. But the way that I know myself is by dragging an image to um, the the actual project, and then deleting it, going to the background. And then once you select on the background, you can go to the properties section and select, of course, the background. There's going to be a couple options that appear, but to select a custom background with an image or any image that you find online or whatever, you would probably like to select the tile brush and go to image source and select whatever image you got off from any website that you wanted, and that's how you go about changing the background of your UI. And of course, there's there's a lot of things you can do to modify your UI, which Lani will delve into later on. But yeah.
Bryan, what is that tool you're using right now that you're showing us?
The tool.
That you just changed it in.
Visual Studio 2019.
Thank you.
Yes. Mm-hmm. Well,
and it's free. You can download it. Anyone can download it.
That is true. Right, Lani. I think your part is next. Lani, is it? Oh,
Lani's having network issues today.
oh no.
Lorpu, can you take over? What's next?
I
Where's the agenda? I think Victor is supposed to go next. Lani was supposed to go and then Victor.
Actually, you'll be agile and go with Victor next.
yes.
You guys
I'm
wanna?
sorry, guys.
Oh, hey, she's back. Save the day.
I'm
All right,
sorry.
I'm back.
Yeah. So let me share my screen again. And what basically Ryan was talking about is changing the background for the user interface for Visual Studio. Let me see. You guys see that again? Okay, perfect. So right here, this is basically the user interface. And for this tab here is basically the coding that we did in class. So this one, the user interface, is where we can actually run the program, and it's kind of the design how we can see how the project works. Let me see. Can you guys see that main window thing?
Yep.
Okay. So when we click on the create button, it's going to be creating some random names. And that was basically essentially what we wanted to create. And so here at the top, we're gonna basically just gonna go through what these kind of lines are. So lines 1 through 14 are the using directives. These basically are the ingredients to build a program and also lets you write the code. As you can see, some lines are colored in black and some are colored in gray. The black lines are the ones that are actually being used on the program. The gray ones are not necessarily used, but keeping them wouldn't really affect the program. Right here is the namespace. This is the same name as I named the program, or yeah, the C#. And then these 3 slashes right here are essentially comments. It's really helpful when you have a lot of lines, and so it kind of gets confusing when there's a bunch of lines. So writing these comments helps the user know where they are in their coding. Right here is the public partial class. So basically, a class is a blueprint that defines data and how they function. So it's partial class because it's split into 2 classes, and so that means it holds 2 sources. The other source is XAML. Right here are string, the right string list, the left string list. Strings are basically just declaring the object is the value and the text. So right here we have brave, lone, fearless up here, and then down here we have hunter, fire, howler, etc. And so basically when you click on the button, it's going to show these names in the text box. And that's pretty much it from my part.
All right. Should I go on to explain Genesys?
Yeah.
Got it. Okay. Lani. So yours is more better than mine, so I'm gonna just base it off yours. Um, so the lower part or the private void create click section is basically the function of the button and how it goes on to um, randomize and select the two strings that are shown above with all the possible name options. It goes on to select those two and randomize it, and it grabs the results of those and adds them together and then displays them through a text box as a result.
Yep, so that basically just helps generate the names when we click on the button. And that's essentially what we did in Jon Genda's class. Next, we have Victor.
Hello. So I will be demonstrating a project that I've been working on for quite a while that has given me a lot of um, knowledge as to what it is that I'm doing and understanding the difference between doing a job versus becoming someone who is a programmer or a coder. So just go ahead and share my screen. Just let me know if you guys can see this.
Yep.
So this is a document that I've been working on just for memory based and for future references if a future engineer wants to work something with ES or Elastic, or if a new Genesys Works intern wants to look at past work and wants to better themselves at doing a similar job position as I am. So the purpose of this project is in my team we upgrade Elastic a lot, and because we upgrade it very often, we had to test scripts, and we had to do many things to see like how things work and how much data is outputting and how much can we store in there. So when I created this document, I had to think a lot about what I did, and I'd ask not only my coworker Nate, not only my supervisor Barry, but I'd ask myself like, what is it that I did, and what did I do wrong, what did I do correctly, and how did I how would I replicate these steps to help benefit me and future references. So EsRally is a place where we can use and test scripts for logging. So what that is essentially, again, with Elastic. So Elastic is a platform that my team uses to analyze and go back and forth with uh, data in real time. And since we're upgrading it, assuming that we're going to need more megabytes, gigabytes, all that stuff, we're going to need more documents and a lot of more testing to see how we can work our way through certain scenarios. So EsRally is pretty much just something that we can perform or compare performances, finding problems, and running races to see how much output we're getting and what it is that we're working with. And again, for the testing, the reason why I did this was because we were upgrading from Elastic from 6.8 to 7.6, and within those files there are a lot of strings that I had to deal with, and a lot of those has pushed me over my limits, which is good. It's something that every engineer or every programmer and coder should go through. And in order to configure all these races and all of these outputs, we use commands. Obviously, I have in my documents how to start with EsRally and what you need and all that jazz. Installing Python, installing Git, installing Java, all through the. In this case, I used Ubuntu, so I would install all of these through the Ubuntu terminal. All those that are highlighted in red, that is. This is just more about setting up, Java, and the reason why I put this here is because, for me, as someone that didn't know anything about coding and programming to learning about things, it's good that I write this because not only is it beneficial to me, but for someone who, the next Genesys Works interns, for example, if they don't know anything, they can always look at this and use this as a reference to better themselves, so that way they would know more than I would. And this is just something that I had trouble with setting up Java. And more in depth about this document. It's just creating files and creating directories. So the reason why I had so much of these is because coding and programming is not really that difficult, but at the same time it is. It's just a lot of really nitpicking and a lot of reading and a lot of simple yet difficult mistakes. It can be anything from spelling errors to wrong parentheses placements, and editing things in the wrong files or directories. And the main ones, or the main commands that I run with, are these ones pretty much here. So EsRally config is just configuring like what is missing and what you need. List tracks is a list of tracks that you've created yourself within that terminal, or sorry, not terminal, within that track. And info is pretty much the info of your track that users created. Distribution version that runs the race, and the second distribution is another race, which is the last race pretty much before you get your final results. Reason why there's two is because the first one is just, it's sort of like how do I say this? It's sort of like a something that you want to test before the actual race. So it's kind of like a guinea pig, and then you have the second race, which is the last one that really matters the most. And along with programming and coding, there will be many errors, again with nitpicking and a lot of reading and a lot of mismatching corrections. And these are just examples of how the files and inside of the directories will look like. Many strings, many, a lot of just madness, a lot of satisfaction, and a lot of work. And this is pretty much what you should get for the final score if you were to, not what you will get, but what you should see once you complete the whole race. And with EsRally, the reason why I chose this to present for this programming event was because it's one of the biggest things that I've done ever since starting my internship. Besides hackathon, besides first day here, first week here, and this is probably one of the biggest things that has really pushed me over my limits. And I figured this would be something that would be really cool to show, because I was basically telling programming my machine to look at all of these things and to try to reach this many outputs. And by doing that, I would have to go into these files and like detect all of these things, whether it be true or false, how many longitudes, latitudes, the names and all that stuff. So, with all of that, it's pretty much what I have to present. And I don't want you guys to see that. I am sorry.
Right. Thank you.
No
Thank you,
problem.
Victor. Next, we have Raymond and Wilson with their Math Problem Solver project.
Thanks, Lani. I've been working with Wilson here on this project to help me make a math problem solver. Let me share my presentation here. All right. Let's see. Can you guys see?
Yep.
All right. So before we start off, actually, let me pull up the program itself. So what it does is actually, it helps you solve math problems. So as you see here, we have our own problem, 6 plus 6, easy, equals 12. And it will tell you that it's correct. I don't think you guys
whatever
can
you're
see
showing,
that.
we can't see.
Yeah. Let me share my screen actually. All right. Do you guys see it?
Yep.
All right.
Not anymore? Yep.
Okay.
There it is.
So we could change the operations of any kind of equation we want. So say if we want division, and then we can randomize any number that we want, 21 divided by 3, which I think is 7. Then I'll just go for may not be at the best, which is correct. But if we also like get something wrong, so like say we want 2 as the answer, it'll also tell you that it's wrong. And that's pretty much my program. I'll pass it on to Wilson to help introduce us to the program and how it works.
Thanks, Ramon, for that. So essentially, I've created the same program actually before, but it was more of a review when Ramon talked about it with me. So essentially, how does it work is there's 4 component to this. There's the equation board, the change operation, the randomized numbers, and then essentially the check answer button. So essentially the equation board, as you first start, it would just randomly automatically show up with zeros. So you will have to fill in those numbers, which will be the X and the Y's and the Z's. And then after that, it just automatically just fill it in by itself. Yeah. The chain of operation is also the operation is chosen by a lock and the key like mechanism built in the code. So essentially, that's what gives you the access to change between the different tables here.
And then right here is the randomized numbers button. So this button right here, it uses the random class, which we can also use to give us a random value of 1 through 10. And then we can also use them to assign the number to show up on the equation board. So on the code here, as you see, if we go back actually to our previous slide, each operation has their own function here. So if operation 1, I assigned it as addition. Operation 2 is subtraction. Operation 3 is multiplication. Operation 4 is division. Going back here, if the operation was 4, we kind of wanted to make it simple as we wanted whole numbers when we wanted to divide. And if we check the code, it'll multiply by y, so it makes sure that we get a whole number as our answer whenever we randomize our division. The check answer button is so when we check the answer, we first get reference of the variables, then we determine what type of equation it is, then we solve it, And if it is correct, a message will pop up, which I showed, which said correct. But if we have it wrong, it'll just show up wrong. Some things we took away from this, it's kind of like a review. So we remember where we learned again how to like assign values to like variables, learn how to use the randomized class, not function. And we also created our own kind of like checking system using our lock and key. Thanks for listening to our presentation, and I'll pass it back to Lani to close us off.
All right, thank you guys so much for that nice project of your little calculator. To end off, here are some resources that we found to further your education about programming. If you guys want to learn more about coding, there are some free classes here on W3 Schools. There's also a pretty cool game on Code Combat for those who are gamers. And then some articles for more coding games and free coding courses. And that's pretty much it for this event. Thank you all for coming.